Hello, today I will show you how to detect and blur the car number plate using OpenCV and NumPy. Let's start with a short plan of what we will do. First, we will set up the code to read and open the image. Second, we will detect edges. Next, we will locate the number plate using contours. After that, we will blur the number plate, and we will finish by seeing the modified image. For this project, we will need only two libraries, OpenCV and NumPy. I will be working with PyCharm IDE. Okay, let's move to the code. We will start with the code setup to read and open the image. First, we need to import OpenCV library. Import CV2. Next, we need to read the image. We create the image variable and assign it to cv2.imread, and in brackets we add the location of the image and an image name with an extension. As you can see, I created a separate folder to store the images and name it images. Let's see what we have in it. We have 6 images. As you can see, image 4 and image 5 are the same images, just one is rotated. We will test how well our number plate detection works with extreme rotation. Okay, let's move back to the code. To show the image, we write cv2.imShow, and in brackets we add window name, let's name it image, and source of what we want to display, image. What's left is to add a couple of lines which will help us to close the window and stop the code. We add if condition to close the window when the escape button is pressed. If the condition is true, it destroys all windows. And that's it. Let's run the code. We can see our first image. We will start with a simple example where we can clearly see the number plate and it's not rotated. And we can close the image by pressing the window close button or escape button. Let's close the image and move to the next part. In this part, we will detect edges. Let's comment imShow line. To detect edges, first we need to grayscale the image. We create a new variable gray and assign it to cv2.cvtcolor, and in brackets we need to define the image we want to grayscale. We add image, and what we're going to do, we will convert color space from BGR to gray. BGR is the default color space in OpenCV. Next, we can show the image. We use the same imShow method, just now we add the window name gray and define the gray image. Let's run the code and see the gray image. Okay, it works fine. We can comment this line. To find the edges, we will use a filter. Let's apply a bilateral filter to the gray image. The parameters will be 11, 17 and 17. With these parameters it works quite well, but you can try experimenting with others too. And finally, we get our edges using the canny method. We add filtered image and thresholds. Threshold 130 and threshold 2 200. And we finish by showing our edged image. Let's run the code and see the result. We can see that the number plate is one quadrilateral contour with 4 corners. We'll use this information to extract the number plate. Let's move to the next part, we will do exactly this. In this part, we will locate the number plate using contours. We'll need the NumPy library. Let's import it. We can comment the last time shown line. First, let's find all the contours from our edged image. We'll use the find contours method. In brackets, we define our edge image. We'll use the copy. Let's write .copy to make a copy. Next, we define contour retrieval mode. We want list, and contour approximation method. We will use symbol. What we will get is a lot of contours. Most of them will be very small. We can filter them by area or using list slicing for sorted list, but I will use all the contours. Let's sort them by size starting from the biggest. We write contours equal to sorted, and in brackets we add the same contours we want to sort. Key how we will be sorting, we will sort by contour area, and that we want to reverse the sort. Okay, now we can search for number plate. What you're going to do is, we will look for all the contours and search for contour with 4 corners. It's a very standard procedure. First, let's define our number plate contour as a region of interest or ROI and assign it to none. Next, let's look through all the contours using for loop for contour in contours. In the loop, we calculate the perimeter, cv2.arclength, and in brackets we add the contour and define that it must be closed. After that, we smooth the contour with cv2.approx_poldp. In brackets we define the contour and the epsilon parameter specifying the approximation accuracy and if the contour is closed. After that, we can check if our approximated contour is quadrilateral with the if statement. If the length of approx is equal to 4, we assign approx to Roy and break the loop. And that's it. But if we also want to crop the number plate from the image, we need to get x and y coordinates from Roy. For that we'll use NumPy library. First, let's convert our Roy to a NumPy array. In p.array, and in brackets we define Roy as a list and dtype or data type. It will be integers. Let's print the Roy to see what it looks like. As you can see, we have a bunch of lists, and we need only one with coordinate pairs. We can do this by reshaping it. Roy.reshape, and in brackets we define 4x2. Let's print to see the result. Okay, we get what we want. We have one list with coordinate pairs in a list. Let's remove the print statements. What next we need to do is to split the coordinate pairs into x and y. We can do it with NumPy split function. We write x, y equal to np.split, and in brackets we define our points, -1 in a list, and x is equal to 1. Okay, we are almost finished. We need to get the min and max values for x and y. It will be our cropping boundaries. We use NumPy's min and max functions for x1 and x2 and for y1 and y2. And finally, we can crop the image to get the number plate. First we define from y to y coordinate and then from x to x. Let's add one more line to show our number plate and run the code. Okay, it works, we have a cropped number plate. In this part, we will blur the number plate. First, let's go to the bottom of the code and comment the show line. To blur the number plate, we will need to use masks. First, we will blur the image, next we will create the mask for the number plate, after that we will create a mask for everything else, and in the end we will combine everything. Okay, so let's start by blurring the image. It's very easy, we use Gaussian blur method. Define the image we want to blur, it will be our image, kernel size, it must be odd number pair, we choose bigger number because we want very big blur, and sigma x. We can show that blurred image. Okay, the number is not readable at all. We can comment this line. Next, we will create the mask for our Roy on number plate. First, we create a black mask. We use the NumPy zeros function. It will fill the mask with zeros. In brackets, we define the size. It will be the same as our image.shape, and we also define the data type. Next, we will fill the number plate polygon with white color. cv2.fillPoly, and in brackets we define the image mask, the polygon to fill our Roy, and the color white. We show that mask and run the code. Okay, it looks the way it's supposed to be. Let's close and go back to the code. Now we create a mask for everything else except the number plate. It's quite easy, we just need to inverse the mask we already have. Let's write mask inverse equal to np.once, and in brackets we add mask.shape.sType, and in brackets np.int8, and we multiply it by 255 and subtract our mask. And that's it. Let's add a line to show it and run the code. Okay, it's good. The number plate is black and everything else is white. The last thing we need to do is to combine all the masks and images. We will use OpenCV's bitwise end method. Let's create a new variable result and assign it to the sum of two cv2 bitwise end methods. First, we add a blurred image and the number plate mask. And second, we add a normal image and an inverse mask. It will add a normal image without a number plate part. And that's it. Let's show the result and run the code. It works. Let's try with another image 1. It works too. What about image 2? It works fine too. Image 3 also works despite the number plate being a little bit rotated. with image 4 is the same, and image 5 also work with extreme rotation. Okay, what's left is to save the result. In the last part, we will write the code to save the modified image. We want to save the image in a separate folder and add the censored part to the image name. For that, we need to separate the image name part. Let's comment this line and add the new lines. We can define the image location folder like this and image like this. So the full path will be adding this together as we have before. And now we show the image using full path. Let's move to the bottom of the code and comment the result show line. So what we want to do now is to save the image in a separate folder and open it. Use OpenCV's write method. civ2.write and in brackets we add the output folder plus file name as a string and without the last 4 characters. We do this to remove .jpg plus censor.jpg and the file we save result. Let's also add the print line showing us that it was successfully saved, and the last 2 lines to read and show the result. We create a new variable saved and assign it to civ2.timeRead, and in brackets we add the same as what we have before. And the last line shows the saved image. Let's run the code. Okay, it opened the saved image and printed the message. This is how easy using OpenCV and NumPy is to detect a number plate and censor it. Hope you liked this video. If you have any questions, leave them in the comment section. You will find the code in the video description. If you liked this video, please leave a like and hit the subscribe button for more Python videos.